Um, so this episode is going to be a lot simpler than the previous two because the concepts that we are covering are just simpler in general. So what I've done here is I've started out with a scene from just something that I've been using for a game of mine that I've been working on. And everything that's here is being rendered with the default Phong shader, which does Phong lighting and texture mapping. So there's no fancy shader effects in here apart from the default shader right now. And I wanted to just pick something that looked a little bit interesting to use as kind of a segue into what we're going to do. So what I'm going to do here is I'm going to pull up this little, I guess you can call it graph, called the multipass or render pipeline editor. Usually I don't go to the shortcut, I just hit Command-Shift-R, but I want to show you guys where it is. And what the render pipeline editor allows you to do is visualize your entire pipeline from beginning to end as far as how your scene is rendered to the computer screen. And when you start out a scene in Verto Studio, basically the default configuration is what just about every 3D single pass rendering scene does, which is a scene rendering pass called main, which is basically the main rendering pass, and the output of that going to the computer screen. There's nothing fancy essentially being done apart from some built-in anti-aliasing that is just turned on by Verto Studio for you. So what I'd like to do is kind of show you guys essentially how multipass rendering works. And in order for me to do that, I'm going to talk about essentially the two types, or the two common types of multipass or rendering passes that are done. And I'm going to explain how those are utilized or implemented by the graphics hardware. This shader series is predominantly designed to focus strictly on the shaders and not so much about the OpenGL system that they run on top of, but this video I might have to go just a little bit into that to explain how this stuff works. So what I'm going to do here is I'm going to start with the simpler of the two types of rendering passes. So there is the post-processing pass, which is you can think of it almost like a 2D pass, and then there's the scene rendering pass, and that's the one that renders all the polygons, and that's basically when most people think of rendering in 3D, OpenGL, and shading, they think of a scene pass or a 3D rendering pass. I'm going to start with the simpler post-processing. So what I'm going to do here is I'm going to click this main node, which is our main rendering pass. I'm going to delete it for no reason. I'm just kidding, that doesn't make any sense. Sorry. I'm going to go ahead and I'm going to, first I'm going to view the output properties so you guys can see what's going on. You'll notice the resolution is essentially exactly whatever you have the window sized to. So right now it says I'm 1135 by 629. If I was to slightly tweak this maybe and then go back, it would basically tell me now that I'm 1139 by 634. There's a checkbox here that says same as display, and as long as that's checked, this is typically what you want for a scene rendering pass, which main is. As long as that's checked, it'll match the resolution to whatever you have scaled on the screen. The pixel format is essentially, this is some OpenGL stuff I don't want to get into so much, so I'm going to gloss over some of this, but basically it's how the color information is stored. Unsigned byte is almost always good enough. How the texture is filtered, nearest meaning blocky. So if you blow up the pixels, they'll look blocky. Linear is, if you blow up the pixels, they'll look smooth. Color format, I have no idea why this says depth 16. That probably is a freaking bug. It's RGBA for main. I gotta fix that. This is a this color format thing isn't exposed in the version of Verto Studio. I'm using that just for my game right now. And I'm off on another tangent. So that's the main pass output properties. Now if I click main and I say add post-processing effect, I can add a post-processing effect to the main rendering pass, and that's a special type of node. I've got all these built-in ones, but they don't let me edit the shader code for those, so I'm going to pick custom, which is the one that I can actually write shader code for. Now what this has essentially done is created a pipeline for me that starts with a scene rendering pass in the main. The output of main's rendering pass goes to the post-FX processing pass, and then the output of that goes to the screen. Now you'll notice that the output properties of main are now editable and the output properties of post effects are not. So the general rule here is that, let me explain how this stuff works. When you do a rendering pass that goes anywhere that is intended to be the input of another pass, basically anything that's not going directly to the screen, the way that this works is you essentially render the scene image to a texture. You actually render it to a texture map. And the benefit of doing something crazy like this, because it seems like why would I want to do that, is that you can now utilize that texture map anywhere you want in the rest of the rendering system. And if you want to do post-processing effects, what's typically done is you will render the previous stage to a texture map, and then you will use that texture map as input into the next stage, hence this post-effects pass. And then the output of that, if there's another stage, that might go to a texture map, or the screen when you're done. So let me explain essentially why you would want to do something like this by editing post-effects' shader code. So, post-effects processing passes, or just post-processing shaders, typically do not allow you to edit the vertex shader in Verto Studio, and that's because it's trivially simple. This is a two-dimensional concept. Essentially what you're doing here is you are rendering a texture map right up at the screen using a full-screen quad polygon. And that's why the vertex shader isn't edited, because typically you don't want to mess with it. It's a trivial thing that just draws a full-screen quad that you texture map with the texture that you just rendered. So I'll show you essentially what's going on here. What you are seeing on the screen right now is actually the texture map of the main rendering pass, or the scene rendering pass, rendered without any fancy post-processing being done on it. I could explain that a little better by actually showing you guys what this fragment shader does. Pass input texture 0 is a special name in Verto Studio's post-processing that tells me that I want to use essentially the first, or the if there's only one, the input from the previous stage in the form of a texture map, and namely a sampler 2D texture map that I can access from the shader. And what this allows me to do is I just retrieve the color here using the texture coordinates input, which is also predefined for me. And then I can use that color in whichever way I see fit. So for example, if I uncomment this sample sepia tone and hit build, I think now it'll start to make sense. I'm actually processing the pixels of that previous stage any way that I want to. And I basically can pull off any effect that I see fit inside the fragment shader of the post-processing effect. And it gets even more interesting than that. I don't even have to sample this thing at the suggested texture coordinates. I just use these as essentially, the texture coordinates of where you would expect to render this texture from. So for example, if I wanted to shift this like an idiot, offset it by 0.5, and stop failing here. Now you'll notice that the entire image has essentially been shifted, and the result is kind of wild. Essentially, I'm actually sampling outside the domain of the rendered texture. I can do this again, of course, the opposite direction. It's also kind of stupid. But what I could do if I wanted to be a little nuts is I could actually take multiple samples per post-processing pass. So for example, if I wanted to say take color 2 and set that equal to another access of the texture, but then I would like to do a small offset, now essentially what I have is 2 samples from the previous shading pass, and I could actually mix those together in some weird way. So for example, if I wanted to, I could say mix the color and color 2 1/2. And now what I have is this weird looking 2-sample blurriness effect, which if I look at long enough I'm going to get a headache, so I better turn off like right now. So that's another example. So you're starting to see there's a hell of a lot you can do in post-processing. And it's one of those things where a lot of games nowadays, or 3D real-time systems, you don't have to pull off complex effects in one pass now, because you can do it a lot of those interesting things you would like to do in post. For example, if I wanted to do this sepia tone without doing a multi-pass shader effect, think about how complex all the shaders would be in my system, because essentially I would have to edit every single shader and affect its color processing, which is just infeasible. But you know, when I do it in a post-processing effect, it's trivial, which is really neat. So some other things I want to talk about before I get too off on tangents here. So I've talked about changing the colors. I've talked about changing the sampling location, taking multiple samples. So what are some other things you can do? Well, really, the sky's the limit. So for example, suppose I've already got this sepia effect, which actually looks pretty cool, right? Suppose I wanted to animate. Suppose I wanted to animate this effect. Well, as you guys remember, if I declare time, it's set for me by the Verto Studio system when I go into fly-through. So suppose I wanted to take this effect and make it flicker almost like you were looking at it from candlelight. What I can do here is I can just say light, I'll call this flicker, and I'll set that equal to the sine of time, which is a sine wave. And essentially what this will be is a very small effect that oscillates between negative 0.1 and positive 0.1. And I'm going to add that to 0.8. And then I'm going to multiply the color by it. So this is the fun part where I realize that Verto Studio does not properly set time for me in a post-processing effect. This is normally where I would give up, but I'm not one for doing that. And I don't know if I mentioned this, but I wrote Verto Studio, so I'm going to freaking fix this right now. So as you'll see, when I hit run, essentially the light will oscillate up and down. Or I should say the color will appear to be flickering. However, I'd like it to flicker with less intensity and with higher speed or frequency. There we go. It's starting to look maybe like it's a picture being viewed from candlelight. I'm going to go ahead and double this, lower the amplitude, see what I get here. There we go. So now we have it almost looks like we are looking at the scene from an old, it almost looks like we're actually looking at it from like an old movie, like an old, one of those old black and white films. So the last thing I'm going to do before I move on here is I'm going to add a vignetting effect, and what that basically does is makes so that anything viewed from a circle that gets further away from the center of the screen will look dark. So we can basically use our flicker color, but I'd like to create a new color here called vignette, and set that equal to 1, and multiply our final color by it. And as you can see, there's no effect done yet, but what I can do here is I can go back to my, I can pull upon my, my knowledge of vectors here by basically determining how far away we are viewing things from the center of the screen. And the way that I can do that is by introducing a new concept that all fragment shaders have available to them, which is basically a vec2 called GL frag chord. And what GL frag chord does is basically provides you with the XY position of the current pixel that you are shading on the screen, but it provides this information in window coordinates, which basically means that they go in a non-normalized coordinate from 0 to whatever the width of the window is, and from 0 to whatever the height of the window is. Now, I'm going to go ahead and gloss over some stuff here because it's vector stuff that we've already seen before. Essentially what I'm going to do is I'm going to implement a circle gradient effect, which is basically implemented by using the distance from the fragment chord to the predefined center of the screen. And basically I do that by converting into normalized coordinates, and then take the distance between the normalized coordinate, which goes from 0 to 1 on both axes, to the center, which is 0.5, 0.5. once I have that distance, I can then use that to determine how far away I am from the center and use a smoothing effect to essentially achieve what is like an old-fashioned camera vignette. One of the things I'd like to do is change this to be larger. I was going to say that I don't like the linear fall off and I'd rather use something more bicubic, and I think I can handle that. So I'm going to show you guys a really invaluable tool in Shaderland, and that's essentially called Smooth Step. And what Smooth Step essentially does for you is allows you to provide a cubic fall off or a cubic interpolation between two values. And essentially that just means it makes it look smooth and it makes it look nice. So what I'm going to do is apply that to my distance value, and for debugging's sake I'm going to use step first. And step is kind of like an instantaneous interpolation or from one value to the other kind of thing. So what I'm going to do is I'm going to set vignette equal to the same clamp as before, but now what I'm going to do is I'm going to say step distance up to 0.25. And what this essentially does is now provides an immediate, almost like circular cutoff. So what I'm going to do is I'm going to switch that to smooth step, and what this does is it says smoothly step from the first value all the way to the second one. So we'll start at 0.25 and we'll go up to 0.3. This cigarette burn thing was not exactly what I was going for, and it probably has to do with the fact that I got a 1 minus distance relationship going here. So if I did 1 minus there, it actually looks a lot better. And I'm going to go ahead and switch this back to step here real quick so I can see what's going on. I have to zoom in here to make sure I got the real proper effect that I'm going for. So you can really dial this stuff in, essentially. I don't want to spend too much more time on this, but you can definitely dial this stuff in and get it exactly the way you like it, and then you basically have a cool old movie-style post-processing shader effect, all done completely in post. So that is essentially post-processing. Real quickly, I'm going to walk you guys through some of the other stuff you can do with post-processing, just by going through some of the other built-in post-processing effects. All of these can be done by writing the shader code manually as well. So I just deleted that one out. I'm going to add a post one called Bloom Blur, and what this essentially does is performs a Gaussian blur of the entire scene. And if one was to set the output properties of this to be something quite low, like 256 by 256, this changes the resolution of the textures that are rendered in each stage. Now what I've done is I've provided a very cool looking blur to my scene. You can even take it a step further if you'd like, and you can actually add another post-processing pass between two other passes. So the best way I can explain this is I'm going to create a scene rendering pass here. Or no, I'm going to create an additive post-processing effect called add. And this one actually allows you to take more than one texture map or previously rendered pass as an argument. So if I set the input properties of post effects, you'll notice that it has not just one or pass input texture 0, but it has a second one, and I'm able to actually add one pass to the other and provide a very, very interesting looking effect. So I'm able to add the output of main all the way to the post-processing effect and add it to the output of the vertical bloom blur effect, or essentially the output of the bloom blur effect. Now you'll notice here this isn't exactly that pretty looking because I've downsampled main to be a low resolution to make the blur essentially be more pronounced. The way I can handle this is essentially I can add a post-processing pass between main and the horizontal bloom blur, which is essentially a custom post-processing effect, and I could let the downsampling happen here. So for example, if I set the output properties of this to 256 by 256, and then I leave main to be its original same as display resolution, something really interesting happens. Now all of a sudden I have something that almost looks like the HDR effect that is done in a lot of modern games today. And believe it or not, this is very similar to how bloom shaders are done. And we've basically done the entire thing inside our tool simply by tweaking and messing around with post-processing effects. Now you'll notice there's one last thing I can do here before I move on to scene passes here. And that's essentially I can edit my downsample pass, and I can let it only pass through to the bloom effect, which essentially gets added back to main, only the values that I deem bright enough to be considered light, or I should say bloom worthy. And this is actually pretty easy to do. If I take color and I convert it to grayscale, I can now use color as a cutoff value to determine whether or not this thing should be shaded. So for example, if color is greater than a half, everything's fine. If it's not, clamp it out to 0. This laptop wants me to punch it in the face today, and it just might happen if this thing doesn't start cooperating with me. That was dumb. I should not have assigned this back to color. What I should have done is called this grayscale. Now what you can see is only the most brightest values, as determined by my fake HDR shader, are being bloomed. So I can actually raise this to be whatever I want. So if I want the cutoff to be, I don't know, 0.75, 0.25, still pretty bright, 0.3, 0.4. So you get the idea. You can do some really interesting stuff here. And if you were to combine this with a true HDR system, which essentially allows you to determine how much light should really be bloomed, you can get some really nice looking post-processing effects in here. So that's essentially a way to handle bloom effects and combine them with programmable shader post-processing effects.